Okay, so here we are still in prisms and cylinders territory. We're moving on to the other major item of measurement that we're going to be doing in class, which is surface area. So last lesson we did volume, which is kind of the amount of space enclosed within a shape, and the surface area now is kind of the amount of material needed to create the exterior of a shape, the total area of the surface of a three-dimensional object. So the surface area of any prism is calculated by adding together the area of each face of the prism. So we're going to logic this out. What I'm going to do is I'm going to peel this shape apart. You'll notice it's the same shape we worked with in the last lesson. I'm going to peel it apart, and I'm going to create what's called a net, an N-E-T. A net is kind of an all-in-one two-dimensional representation of a three-dimensional shape. A net is something that if you fold it up, it will create that exact shape. So the net of this here is going to look like we're going to have one rectangle. We'll say that's 20 by 8. So that's this front piece. And we're going to have a rectangle on either side of it. And this is by, I don't want to put that there. That on the inside, that's 9 centimeters and 9 centimeters. So you can see those two rectangles I added are this rectangle and the corresponding rectangle underneath. Now the sides, you can put on either side here, they are 9 by 8. I have 1, 2, 3, 4, 5. If I fold that up, I'm going to be missing a side, so I can put the remaining side right there, which is 20 by 8. That is a net of that three-dimensional item right there. So you can picture this in your head. If you fold that up, you fold the top, you fold the bottom, the other side comes up the edge, the two ends fold in, that's going to be your rectangular prism. So let's look at the area of each face. I'm going to change to green. The area of this is 20 times 9, which is 180. Okay. The area of this is 20 times 8, which is 160. The area of this one is 20 times 9, which is 180. The area of this one is 20 times 8, which is 160. I hope you're seeing a pattern here, guys. The area of this face is 9 times 8, which we know is 72. The area of this one is 9 times 8, which is 72. Then I'm just going to add all of them together. But let's take this and look at the formula that we're going to get. So the surface area, SA, is, we have 1, if we say this is length, this is width, and this is height. This first one here, we'll call that number 1, is the length times the width. Length times width. And how many length times widths do we have? We have 1 here, and we have 1 there. So we have 2 length times width. We're going to add those 2 length times widths to, let's look at this one here. I'll change color again, a little light blue. Go to this one here, which is length times height. And how many of those do we have? We have 2 of those. I'll change color again, go to orange. Then we have this one here, which is width times height. And we have 2 of those. So what we get for a formula is surface area is 2LW plus 2LH plus 2WH. So it's just every combination of the dimensions, multiply them together, multiply by 2 because you have 2 of each of them, and then add them together. And that works for any rectangular prism. So I'm going to put a little star here. That is for rectangular prisms. How would that work for a triangular prism? Well, let's take a look. Let me draw a triangular prism for you. Okay. Now remembering that we need, this is the height, that's the base, that's the length. If I make this into a net, I get, let me see if I can draw this, triangle with a, well, that's not very good, hold on. I'm usually quite good at drawing these things. So let's say I have a rectangle, a rectangle, a rectangle, a triangle, a triangle. That is what the net of a triangular prism looks like. And if we say that we have side A, side C, that then we would have C, A, B, and L. Okay, does that make sense? So you can see if this length here is side C, this face is C times L, which is the same as that face there. And if this outside is A, right there is A times L. And if this side is B, right here is B, and you get B times L. So let's write out what the formula would look like. So we're going to have the triangles are 1/2 base times height. How many triangles do I have? I have 2 of them. Plus, I have 1 triangle that's A times the length, plus 1 triangle that's B times the length, plus 1 triangle that's C times the length. So in reality, those cancel, and I get BH plus AL plus B. Why does that say BC? Man, you guys should stop me when I'm doing something silly. BL plus CL. So that's what happens when you have a triangular prism. So it's not super different if you think about why we create the equations the way we do. This topic is really an application of thinking and logic. If you just blindly apply the formulas, you're going to apply the wrong formula to the wrong shape and vice versa. If you understand why we make the formulas the way we do, then you'll never make a mistake by using the wrong formula because you will be thinking critically about what shapes you need in order to get the correct formula. So now let's go down and let's look about cylinders. Remember, cylinders are secretly prisms. We just don't call them prisms because they have circles in them and circles make them special, but they really are prisms. And the net of a cylinder looks like a big rectangle, and it has 2 circles like that. It's a terrible circle. Ugh, let's get rid of that. Try that again. Like, there we go. That. That is the net of a cylinder. So, if we think about it, that distance around the circle is the exact same as that length there. And the height here is this height there. The only thing we're missing is the radius. So that is the net of the cylinder. And what we have two circles plus one rectangle for surface area. And a circle, we remember the area of a circle is pi r squared, so we're going to multiply that by 2. And the rectangle, funnily enough, remember how I said that the distance around the circle was the same as the length of the rectangle? What's another way to say the distance around a circle? That's the circumference. The circumference is 2 pi r. So the area of this rectangle is 2 pi r times the green part, which is h. So 2 pi r h. And that, I'm going to give you a hint here, is called the lateral area. So if you see that in your textbook, the lateral area is talking about the rectangular part of the cylinder. So let's calculate this. We have 2 times pi times the radius is 2.2 squared plus 2 times pi times 2.2 times the height, which is 5.0. And now we're just going to add it together. Handy dandy calculator. 2 pi times 2.2 squared is 30.411 plus 2 pi times 2.2 times 5.0 is 69.115. I'm keeping 3 decimal places on purpose. I'm only going to use 1 decimal place in my answer. So I always keep at least 2 more decimal places than I need to avoid rounding error. So I'm going to add 30.411 back onto that. And I'm going to get 99.526, which I'm going to take over here. I'm going to round. I'm going to say the surface area is 99.5 centimeters. And what are the units of surface area? The units of surface area, because we're just adding together a bunch of 2-dimensional things, is centimeters squared. Same as any other 2-dimensional area.